myself around. Excellent. So, second set of FiReStarters, and today, 5 more guys. Again, I guess a slight bias here towards biotech, and we'll come to that. I guess I'm just going to take you guys in order because with the order in which you're sitting. So, Soroush, first of all, we are back on graphene, which of course is a hardy perennial at FiRe conferences. But tell us more about how you, NanoXplore, are expanding the application of graphene, where it's going, where it's most exciting right now, and where you're seeing the best opportunity.
Right. So NanoXplore is a graphene manufacturer. We're based in Montreal, Canada. We're producing graphene from natural flake graphite. So what we do is we get graphite from the north of Quebec, bring it down, and exfoliate it layer by layer. I think you know about graphene. It's great material. You know, it has high thermal conductivity, electrical conductivity, is mechanically strong, and it's all good things it has. And it won the Nobel Prize 2010. And so it's a new and advanced material. So what we do is we manufacture this graphene. It's a powder. It's a fluffy powder. And we put it into different applications. Now we are active in 2 markets, plastics and energy storage, lithium-ion batteries. We put it into the plastic for increasing the mechanical strengths. Technically, wherever we see metals, we want to replace it with the plastics. Plastics are in general lighter than metals. They don't rust like metals, so there's a lot of interest to replace metals with plastic, but they're not good enough.
So where are these plastics being deployed, mostly?
For instance, in the transportation, in the electronic packaging, you know, it has applications in the structurals. Plastic goes everywhere, but most of the applications, plastics are not good enough to compete with metals. They're not as strong. Think about a car, aluminum chassis. If you want to replace it with plastic, it's going to break right at the point. So adding graphene to those type of plastic increase the mechanical performance, increase the thermal conductivity. It cools down the plastic. For electronic application, you have electromagnetic shielding properties that graphene brings to the plastic. So that's the core, and that's where we make our money on the graphene. Another segment is lithium-ion batteries. Technically, to increase the range of the electric vehicles, you either need to increase the capacity of the batteries.
The cathodes within the batteries, is that what you're using?
Both cathodes and anodes.
Right.
So we put graphene both in cathodes and anodes. Anodes are technically a spherical graphite today, but there's a problem with the graphite supply, so we put silicon graphene compound.
Okay, and just give us the big pitch then, the speed of expansion. I mean, for you and for the industry as a whole, as you're seeing it right now.
So technically, we see a lot of potential demands in electronic packaging for the graphene. And we think that if we turn the company on the cash flow positive situation, we can actually dominate that market and go to the other niche. So for us, the main activity is in the plastics, in the electronic packaging, the short term.
But I mean, the speed of growth for you, you've been around for 3 or 4
we have been around for around 4 years, and we increase the revenue by 5-fold every year.
5-fold every year?
Yeah. So things are going good. We hope to maintain that. It's kind of pattern that doesn't happen next, probably. But we would like to grow the 5-fold next year as well.
Wouldn't we all? Caitlin, you don't have to grow 5-fold every year to interest us, so don't worry, there's no pressure. Tell us more. Tell us about you. Again, this is biotech, and this is a very specific medical condition, medical complaint, which has huge significance for the medical industry, right?
Absolutely.
Tell us about your.
Sure. OtoNexus Medical Technologies has developed an ultrasound medical device for the accurate diagnosis of middle ear infections in children and also in adults. So I have a question for the audience. So who here has either ever had a middle ear infection or has dealt with a child who has had a middle ear infection? And there you are, the entire room, which just shows the absolute ubiquity of this problem. Very nearly every child, 93%, will suffer at least one occurrence of a middle ear infection severe enough to have to see the doctor. And the vast majority of those children will suffer repeat occurrences up to a dozen or more in childhood. And this problem, the biggest problem, is that otitis media, which is middle ear infections, is the #1 reason for antibiotics in kids. It's the #1 reason for surgery in kids. Yet clinical studies show that doctors get it wrong 50% of the time.
So this is misdiagnosis of the condition, and you have, I mean, I've seen it, but this is a specific, oh, there it is. Okay, there's a bit of kit put into the ear, and you can, I mean, how rapidly can you literally identify, well, actually tell us how you identify the nature of the infection, whether it's viral or bacterial, and the difference that that makes.
Right. Which, of course, is the exact problem that we're trying to solve, is there's massive overprescription of antibiotics in this space, and we have the world's only technology which can accurately differentiate when and when not to prescribe an antibiotic, which solves that problem. So we use Doppler ultrasound, which is a very well-known, very safe technology, and we apply it in a completely novel way to the ear, in a very simple, very elegant, easy-to-use, inexpensive solution in a device designed for primary care, pediatricians, and other GPs, just quick and easy to use.
And it spots the effluent effectively in the ear, right? And that gives a signal whether you're dealing with a virus or a bacteria, and therefore whether antibiotics are appropriate.
Exactly. There's actually 4 disease states that we're looking for, looking specifically at the viscosity of the fusion or the thickness of the fluid on the other side of the eardrum of the tympanic membrane.
And where have you got to as a company, briefly then now? I mean, where are you at in terms
So we're very late stage product development. We're just about a year away from market entry. Right. And we have just, by the way, tremendous pull, as you might imagine. We've been testing it extensively with pediatricians and other physicians who are our target market. They seriously want to be able to comply with the new American Academy of Pediatrics and other CDC guidelines to reduce antibiotics, but they don't have any good tools. So they see this clearly as the right tool.
Terrific. Okay, let's move straight on. Robin, tell us about you. Tell us the name of your company and what you're doing.
Yeah, it's spelled with the number 3, so it's pronounced Origin. And we are a regenerative medicine biotechnology company. We use some of the newest technology on the planet, and we use it in a pretty interesting way direct to consumers. So the technology is based on the ability for us to take a few drops of anybody's blood and then reprogram it back to a 3-day-old state and turn that into an induced pluripotent stem cell. And from those cells, we can then differentiate those cells into any tissue of the body. So for instance, if we were to take some of your blood cells, we could turn it into your beating heart cells, and they would actually start spontaneously beating in a petri dish with the same rhythm as you. So if you had a genetically inherited cardiac condition like long QT syndrome or hypertrophic cardiomyopathy, you could actually measure that misfire in the petri dish. So that's the base of our technology. And what we've been doing over the past 2 years is we actually go directly out to consumers. And we've been to 200 different cities this year in the United States, and we ask consumers directly to contribute a small teaspoon of their blood for our biobank so that we can create a representation of humanity for modeling diseases and for modeling drug treatments. And we've seen over 8 million people this year, 200 different cities. We have hundreds of phlebotomists collecting blood. It's kind of a strange thing to talk about, collecting blood.
So you have 8 million droplets of blood stashed away somewhere?
We don't have 8 million droplets of blood. We have 8 million people walk within 30 feet of one of our blood collection facilities, and then there's a conversion rate that we have. We have thousands and thousands and thousands of blood samples at this point. If you combined up all of the other blood banks that are doing any kind of stem cell research in the planet, ours is multiples bigger than all of them combined at this point. Pretty fascinating.
Just to talk pure commerce, in the near term, who are you going to sell to, and what is it you're exactly going to be selling them?
Yeah, so our business is split among 3 different main components. One is we collect these samples, and then while we were collecting samples along the way, we learned something really interesting about the people that we're collecting from. A lot of them said, hey, can you tell me something about myself? And we said, we really can't do any diagnostics. But then they really insisted, and we started developing these personalized genetic tests that are lifestyle-based. And you'll see some of them outside. So for marathons and triathlons, we sell a product called FitCode, which tells you 27 genes of fitness. For Comic-Cons, which is a really interesting demographic, we have a genetic test called Superhero that tells you if you're an outlier with strong bones or language learning skills. And for health and beauty events, we have a product called Aura that tells you your skin sensitivity, collagen breakdown, skin aging potentials. And strange thing happens, we have a conversion rate. For the people that donate blood, a certain amount convert. We'll want to buy a product to help support our research, and they'll learn a little bit about themselves. So it's a really interesting hybrid business that's some bio and a lot tech mixed in, and we're using this really wild technology where I walk in the lab every day and look at little beating heart cells, and it's really, really amazing.
Wow. Okay, we refer there to outside. There's, of course, there are a lot of aids, as you will have noticed, out in the hall with different companies, many of them FiReStarters, and I know that Talbot's got something out there because he's shown it to me already. Talbot, you didn't bring with you your Lego bricks, but...
and I'm going to ask you, Ed, to give me a minute, I'm going to ask Bill to bring in too, and if you go to the...
Okay, Bill.
Because I think it would help.
He's on the case, in which case I'm going to skip past you, just in the interest of brevity, and ask John to tell us about your company. John.
Sure. Well, my company is Metabolon. I'm the founder and the CEO of Metabolon. And what we are is a healthcare technology and delivery company. And so we've got a very unique technology. We're by far the leader in the world in this. It's called metabolomics. What we can do is take a sample, and that could be a blood sample or a sample of urine or cerebral spinal fluid or anything like that. And we can measure all of the small molecules all at the same time in that one sample. And we can quantitate that. And so we're getting very quickly a reading of what's happening in an individual in metabolism. And so... Yep.
So it's an analytic technology.
Right.
You take the samples, because obviously at the moment, right, most doctors testing for a problem will be testing for one problem at a time per sample.
Right.
Yeah? And you can do a huge spectrum of problems or conditions
Right.
with this one piece of analytics. And you're set up inside hospitals? I mean, where do the samples go? Where are they being?
No, we're a central testing lab, and so people will send us the samples, we'll do the analysis and send them back. And so, in a human, most humans have about 2,000 small molecules in their blood. And so if you get an early stage of a disease like type 2 diabetes, we're going to see it 5 years before anybody else does. And so we can do healthcare monitoring. Our main commercialization up until now had been with pharmaceutical and life sciences companies, and so we've applied the technology to about 5,000 studies. For instance, we've done 75 liver studies, and so we've seen what liver disease looks like from all kinds of angles and have built up a large relational database on that. And then we can use that to then interpret the rest of the data. So we can take a sample from a normal person and tell them if they look like a healthy person or if they don't look like a healthy person. And so we're launching products like that now. We just launched a test today that will actually would be able to look at about 65 different metabolic disorders in a very small amount of blood. And this is really important for childhood inherited disease. And so we're launching that through a lot of genetic centers throughout the United States. And we've been working with that with Baylor College of Medicine. It works great. And now we're starting to go to the other medical centers.
You are expanding fast, right? I mean, you told me that you're not just limited to the US anymore. I mean, you're actually traveling.
No, we actually are in Europe. And in Europe, you can go direct to consumer, where it's really difficult to do that in the United States. So we're starting to investigate that, for wellness for consumers, and looking at various other applications. Sports medicine is a great application, like Robin said. So we'll probably be there in a booth next to you one of these days. And so there's various verticals that you can go through with our technology.
We talked a lot about speed of diagnosis. I mean, is there a speed kind of guaranteed in terms of the speed at which you're delivering the news about what you're seeing?
Right. Yeah, there is. And if you want to get a confirmed diagnosis on a metabolic disease of a child right now, it's going to take you probably about 3 months because there's a lot of different testing that has to happen. We can do it in about 21 days, and we'll be able to cut that time over time as we scale. We think it's going to really change the way people look at their health, because, if you pick up type 2 diabetes when a person has not yet become dysglycemic, all you have to do is 2 or 3 weeks worth of exercise and diet, and you can get back to normal. So, it's a major step towards prevention.
Great. Do we have your Lego bricks here?
I think so.
Here they are. They're not carried lightly. I mean, they are not light. I have to say, I tried to pick one up earlier, but these are prototypes, right? So
these are the prototypes. They're robust. They're definitely made for launch environments.
Okay. So now this is quite a complicated story, and it involves space junk and solar panels orbiting the Earth and so on. But just very simple terms, show us what they are and tell us how you're hoping to apply those.
Well, I'll see if I actually have a... So what are they? Interesting, I'm sitting next to a stem cell. The idea that space is the final frontier, we've heard the catchphrase, but it's been pretty limited to large corporations, governments, and billionaires. What we've tried to do is not only assist that group, but to enable the next generation of dreamers and make visions into substance. These are space bricks. They are Legos. They've called Raspberry Pis in space. They have a lot of different terms. We call them HISATs, hyper integrated satlets. They're a biologically inspired design of a stem cell. What that means for space is that it has everything you need to go to space in it, from power generation, power storage, communications, propulsion. I'm trying to think about processing, metrology. It's a full-up spacecraft in a box. But its real advantage is that you get to build with it. Just as you were a kid, it is designed to sort of lock together. And in that locking together, and it can actually, let me unlock it. You can form different structures. You can build on top of it. It can get very large. It can get very small. The advantage here is to try to give the next generation who's dreaming of what there is to do in space the actual ability to use these cells in a biological manner to aggregate together what they want to build. And
there are visualizations on the video out there right in the hall, which just will perhaps show better than we can describe, just the types of things that you might want to build. For example, a larger solar panel. You've already sent some of these up to the space station, I believe?
To demonstrate the ability that they can make a spacecraft, a larger spacecraft, we've sent some to the ISS with the help of Cassis that was on stage earlier. They've supported us. We put our own money into that so that you can get that on board with the astronauts to just show how, students, anybody can put these together, make a spacecraft, and send it out into orbit.
I loved, you also explained the costings of these things. Now, perhaps you should just talk us through these, because as you say, this is supposed to be space for non-billionaires.
Yeah.
Talk us through, and obviously it's not right now, but the future, the short-term future pricing that you're envisaging, for example, around some of the more simple constructions that people might have an eye on.
We've been approached, people want to make a power station in space, This is an easy building block because it can scale. We can't put the size of objects currently up easily. With the building block, you can scale to very large sizes. You can make those solar plants, solar gas stations in space that can help the Earth. You can make space docks so that we can build for going out into the universe. We're supporting Air Shepherd right now in making a system that these are affordable to a community who wants to support the endangered species and watch elephants and rhinos. A small group, collective, could buy this, put a sensor on it, launch it, and watch elephants. You could put the video up in the corner as you do your homework, as you do your evening news report, and watch our pod, watch a herd, and if you see it endangered, you can report it immediately on the internet. There's a lot of applications of involving the community, involving the social network, involving the bigger group of humanity in space. And we haven't done that. We've relegated it away. So this is in that price of a car range. It's not a $1 billion endeavor.
You were imagining tens of thousands of dollars for that particular watching the elephants idea, right?
Yeah, this is a mass production item. So it, very simply, because we've reduced space to a cell that you can mass produce, the more we use, the cheaper it gets. So the price of a car, you make one, it's going to be a Lamborghini, but you make enough and it's a Hugo. So
sure. People, questions, please do step forward if you have any for any of the FiReStarters today. Now, right now, obviously, you were also imagining kind of clearing up space debris. You could use these for that. You've got the astronauts, right, building their own little mini space vehicle.
Yep.
What is the propulsion on that? I mean, I know it's got solar panels, and I know it's got some kind of communication. Well, what hasn't these days? But how exactly does that fire itself through space?
All around the outside, there are small thrusters and jets just built into it. And as you aggregate more, they get bigger and better and more capable. They get more resilient. They understand space. You don't have to. You don't even have to think about how to support your space item. It will take care of that. It'll keep your orbit. It'll maintain it. It'll keep your pointing. You just tell it what you want to do. If you want to look outward, you want to survey stars, you want to make a ship, you want to look downward and support exploration on the planet, Yeah, it's that idea that is going to energize not only our existing industries, but the next generation of industries.
Yes, sir.
So, questions for the metabolomics and the stem cell, if we have time. The metabolomics. So there's a push, growing push within the Department of Energy right now in the U.S. and also within the BBRC in the U.K. To try and do deep metabolome annotation, to try and understand. So for those who aren't metabolomics aficionados in the audience, in metabolomics, you compute mass spectra, and for a relatively small subset of the spectra, you can identify a compound that gave rise to it. Okay, and for the vast majority of it, so if you get 200,000 peaks, you can say what maybe 100 or 500 actually are chemically, and the rest are dark matter. And so my question, potentially there's a lot of money about to be dumped into that, and it obviously has scientific applications, but will it help your business if you know more about the chemistry underlying the metabolomic signatures, or no, you just need the signatures?
Yeah, no, what you're referring to are what academic scientists are doing, really. I mean, we're probably 10 years ahead of those guys. And so we've written about 2.5 million lines of software code that actually go into that very, very complicated data coming out of a mass spec. And we can separate what is noise in that and what is actually signal coming from biology. We can interpret what the molecules are, and we can quantitate that. We can then form it into metabolic pathways and understand exactly what we're looking at. And so we built, if you will, an ontology based on that. So the beauty of metabolism is you have most of the ontology already worked out, but then there's a higher order of how do these pathways contribute into disease. And so that's the type of data system that we're developing now. And yeah, and we're working with a lot of those groups right now. But the academic labs are very hamstrung because they don't do well at being able to bring mathematicians, physicists, software designers, engineers, and people like that all together where a company can. And so that's the advantage that we've built up now.
That's great. And so for the stem cells, an unbelievably exciting resource. I instantly forwarded your company's webpage. So really interesting unanswered question in cancer. We have some cancer interest here. Is etiology. How does cancer begin? How does it progress? When do you get a metastasis, et cetera? How does cancer evolve through space and time? And that turns out to be very, very different depending on human genetic background. So maybe now you have a really incredible resource to study cancer etiology. There are protocols to make very limited numbers of genetic perturbations in an IPS background to generate, not necessarily malignant, that's still, no one knows how to do that, but generate a truly immortal a line that has good malignant potentiality. So are you guys interested in collaborating with some of these cancer etiology consortia?
Yeah, we'd love to. I mean, that's one of the things we do every day. We create these immortalized IPS lines in our lab. We have disease patients that are collected through foundations. So we work with foundations such as the National Parkinson's Association. We grow neurons in our lab too, not just heart cells. So we grow neurons, and we can model the neurologic degradation of things that are happening with those particular patients versus healthy normal. And this patient population process has been, to me, extremely fascinating. The things that we've seen in our lab, just from the diversity and the population pool that we have access to, is amazing. And we want to share that as much as we can with other collaborators. The other thing that's really important to understand is that when we get these samples, they're uniformly consented. So that was one of the very first things we did, is to make sure that we had full consent to do whatever we want with the cells after we have them in our laboratory in perpetuity. And that changes our head thinking a little bit about how we aren't really, at first, we think we're a commercial entity, but after you have, all of these humans in our cryobank, you start thinking, wait a minute, this asset's going to be here long past us. And so now we think of ourselves more as custodians of this resource that's there for the planet. And it's not just US-based. We're collecting in Africa. We're starting a collection facility in China. I'd like to get indigenous cultures into this thing. So, I mean, there's an approach and kind of a method to where we want to go to get these samples.
That is incredibly exciting. Does the NIH recognize your uniform consent as including genomic consent?
I'm not quite sure how the NIH thinks about this because, again, we're commercial, right? And so there's all these ideas about precision medicine and these concepts that are out there, and there's grants that are, RFPs and grants that are out there. But those things take years, and in the meantime, we just went ahead and just did it. And so I think it makes people's heads hurt a little bit that are in academia. That how are they doing this? And we've heard these comments come to me all the time, like, how are you doing this, or why, who let you do this? I'm like, we didn't ask permission. We just went and did this, and the permission is from the person that's donating the cells to us. And I think that's the most important part, is that we have a really close relationship with the donors.
Well done.
Are there any data protection issues here?
Yeah, we're very careful with the data. So I'm also a privacy nut, so I worry about privacy. When samples come in, we anonymize them away from the donor so that we actually have an origin registration number that we keep and we separate from the individual. So again, we capture all of the like genomic data, any kind of disease-related data, but we try to separate that from individual, name, address, that kind of information.
Okay, guys, we are out of time. So thank you very much. Thanks for my FiReStarters.
Yeah.